Good morning, Tehmina Khan is here in TKMaths S1. In today's video, which is in continuation of the A-level mathematics M1 lessons, we are on lesson 4, which is on force and Newton's law of motion. So in this topic, we will cover these subtopics. And in this first video, I will cover Newton's first law and Newton's second law. For the rest of the videos, I'm putting the link in the description below so you can refer it to watch the other videos. So let's start. What is Newton's first law? Newton's first law is saying every particle continues in a state of rest or uniform motion in a straight line unless acted on by resultant external force. So basically we will see here two things when the thing is in the state of rest or it is in the state of uniform motion. So I've taken here two examples. So first case, when the body is at rest, it will remain at rest. And if body is moving with uniform motion, it will keep moving in uniform motion until and unless there is an external force, right? So a body at rest, if forces act on a body and it does not move, the forces must balance. Hence, if a number of forces act on a body and it remains at rest, the resultant force in any direction must be 0. So what does this mean? Let's understand it with the help of this question. You can consider that this is a block, right? And all the forces acting on it are shown with the help of the arrow. We have to find the value of x and y, and what is given here, that the body is at rest. Now if you see here, this is upward 50 Newton and downward there are two forces, y and 10 Newton. Body is not moving vertically. So what does this mean? So I can write here that vertically 50 Newton is actually equals to y plus 10. That is the reason body is not moving vertically. So you can say y is equals to 50 minus 10, 40 Newton. Right. Now we have to find out x. Since the body is at rest, then all the forces which are acting in the right direction, right side, which is 50 and 10, is equal to the one which is on the left side, which is x. So I can say horizontally, also there is no motion. It means x is equals to 50 plus 10 Newton. So this is 60 Newton. So I have found the value of x force and y force. This is the situation when the body is at rest. Now let's consider Newton's first law of motion for the case when the body is in uniform motion. Now what does it say? I have already explained, but let's repeat it. A body can only change its velocity, that is increase its speed, slow down, or change direction, only and only if external or resultant force acts upon it. Thus, if a body is moving with constant velocity, now this is important, with constant velocity, then there is no resultant force. So you can say it is equivalent to at rest. So something is moving with uniform motion, so you will deal it exactly the way you deal the forces in the rest position. So let's see this example. So body is moving horizontally at a constant speed of 5 meters per second. So in that case, if I have to find vertically and horizontally, I can say vertically, just like the way you have done previous one, right? So these s and this s, they are acting upward, whereas 2000 is acting downward. So what will you do? Tell me. Yes, you're right. S plus s is equals to 2000, which is 2s is equals to 2000. It means s is equals to 1000 Newton, right? Now horizontally, if I have to see, body is moving, it is not at rest, but it is moving with the constant speed, constant velocity. So that's why this will also be taken as P, which is right hand side force, will be equivalent to the one which is left hand side, 300 Newton, right? Now Newton's second law of motion. Newton's second law states that the resultant of the force, resultant of the forces acting on a body is equal to the mass of the body multiplied by its acceleration in the direction of force. So what does this mean? Mathematically it means F is equals to ma. Now let's see here. Suppose this is a book, right? It is on your hand, and if it is at rest, then R is equals to mg. These two forces, you can hold any book on your hand, and if it is still there, it means R equals to mg. R is the reaction force, right, which your hand is applying on the book, and mg is the weight of the book. So weight is always shown with mg, Newton, right? One thing I will tell you here, that g is representing gravity. Mostly in physics we use 9.8 value, but in mechanics, in mathematics, we use it 10, right? So whenever I will replace g by the value, I will use 10. This is like a stated thing in this syllabus, and mass will be given to you in kg. Okay. Now if there is an acceleration, it means you are moving your hand up. So how will this Newton's second law of motion will convert into equation of motion, this situation? If this book is going up, it means this force is more than the weight. Agreed? It is a common practice also. So you will write here R minus mg equals to ma. Whereas if you hold your book, and suppose book is very heavy, and then you are not able to hold it there or able to move it up, rather it comes down, it happens sometime. In that case, the Newton's second law of equation will be mg minus r equals to ma, because in that case your acceleration will be in the downward direction. You get it? Right now if it is written like this, because acceleration is upward, so this force is more. But if it was other way around, then I will write mg minus r. Let's give some values here and see how does it work. Okay, so let's see, the weight of the book is 0.8 kg, and the this is the mass. Okay, and the acceleration is 0.5 meter per second square. Then in that particular situation, and I'm considering it, the book is going up, okay, as it is shown in the question. So in that case, the equation of motion will be what? You have to substitute values in this equation because it is accelerating upward. So what will happen? You will replace the value of m by 0.8, g, gravity, you will replace by 10, mass is again 0.8, and acceleration is 0.5. So you got r is 8.5, right? So what does this mean? You are feeling heavier, and actual weight of the book is 8 Newton. That is the interpretation. Sometimes interpretation is also asked, but that is very rarely. Now let's solve this question very quickly. If you want to put the video on pause, you can. Otherwise, I'm solving here with you fast. Okay, so you know when the double arrow is here, that shows you the direction of the acceleration, right? In that case, how you will apply the Newton's second law? Let's see. This is the Newton's second law, F is equals to ma. So because it is resultant force, body is moving up, so x is more than 10g. So I will write x minus 10g, and g is again 10. Mass is 10 kg, it is given to you here, right? And acceleration is what? 4. So you can take out your calculator quickly. 10 times 10 is 100, and it is 40 plus 100, so it will become what? 140 Newton. So the force X is 140 Newton. So this is part A. Let's do part B. In that case, every value is same, but the acceleration is happening downward. So what will you do now? Tell me. Absolutely right. It means this force is more than this force. So now you will do 10g minus x is equals to ma. I am actually plugging in values in it, right? So m is 10 and a is 4. So it is 100 minus x equals to 40. So 100 minus 40 equals to x, which will become what? 60. Absolutely right. So your x is 60 Newton. And what will you do in this case? Last case. Again, acceleration is happening downward. It means this is greater force compared to these two which are acting upward. So if I write here the resultant force in the Newton's second law, it will become mg minus, and I will add these two or I can subtract these two separately, your choice, right? Mass and acceleration is 0.8. Pick up your calculator, please. So it is 10m minus 27 is equals to 0.8 m. So the terms with m, I'll bring them together. And then just like algebra, I will solve it. So it will become what? 9.2 m. Okay, if mass is, for example, not exact, then you can write value in 3 significant figure, which is mostly stated on the cover page of the examination paper. So suppose it is 2.9347 as per my calculator. So it will become 2.93 as per 3 significant figure. This is the mass, and mass is in kg here. So I hope you understood this. Now this is your time to check your understanding. This is the last question of the video. Then Newton's third law we will do in the next video. So you can put the video on pause. I have already solved this question and I will show you the solution, right? And I don't think there is a need of explanation. It is exactly what we have done. I have given this question to test your understanding. Okay. So I'm showing you the solution now. Explanation is also given here, exactly what we have done up. We have to focus here on 4 cases. Lift is at rest, moving with constant speed, accelerating upward, accelerating downward. These are the 4 cases we have studied in so far in Newton's second law. These are the questions again I have written here for quick reference. So now at constant speed, I told you it remains the same. And what will happen when it is acting downward? Absolutely right, mg minus t. Right. So we will end the video here, and next video will talk about Newton's third law. So thank you very much for watching the video. Please press like and subscribe.